Hello everyone, today I proudly introduce our project, an adaptive hand exoskeleton for dedicated rehabilitation assistance. Nowadays, about 30 million people worldwide are disabled each year due to stroke. The stroke patients experience paralysis or weakness and require rehabilitation. However, compared to the big joints, the rehabilitation of hand turns out to be more difficult because of the small working space and more degrees of freedom. Human fingers have 21 degrees of freedom, so it's difficult to pay attention to every joint during rehabilitation. Doctors feel that the importance of fingers decreases from thumb to little finger. Also, the study found that thumb participates in 94% of grasping, and 40% of hand functions are completed by thumb. For example, in paper folding and other operational tasks, the role of the thumb is usually irreplaceable by others. The exoskeleton was designed considering the importance of different fingers. In total, 6 motors are used. The thumb is driven by 3 motors, which can perform thumb coning motion. The index finger is driven by 2 motors, and other fingers are driven by 1 linear motor. Human thumb is composed of the CMC, MCP, and IP joints. CMC joint can realize the adduction, abduction, and flexion extension movements. In our exoskeleton, the thumb flexion extension is driven by Model 1 and Model 2, while the thumb adduction is driven by Model 3 using gear rack mechanism. Motion compatibility can ensure the safety and comfort of exoskeleton with some redundant degrees of freedom in the closed chain mechanism, including passive joints and sliders. Our exoskeleton realizes human motion compatibility. For example, when the slider is unblocked, human motion compatibility can be achieved. However, when the slider is fixed, the passive degrees of freedom in the closed chain is reduced, resulting in human machine movement incompatibility, which can produce harmful tangential force, and the bondage is broken. Also, to deliver a friendly appearance and ensure the safety of the patient, an elegant exterior was designed. All sharp parts of the exoskeleton are covered. In conclusion, our exoskeleton can realize dedicated hand rehabilitation due to 3DOF independent joint actuation of the thumb and can achieve better human machine capability with its fully self-aligning ability. With our exoskeleton, users can finish precise and complex movements as shown in the videos. For the last part, we'd like to show you some interesting applications for our exoskeleton. The first application is to assist stroke patients with daily operational tasks. With our exoskeleton's assistance, patients can perform activities of daily living that would otherwise be impossible. It is of great significance to realize the patient's self-care ability, which can maintain patients' self-esteem and improve their quality of life. The second application shows a golden miner rehabilitation game where the patient wears a data glove on the healthy side and our exoskeleton on the affected side. The data glove controls both the game operation and the opening and closing of our exoskeleton. The third demonstrates a kind of mirror movement rehabilitation. The surface electron myography is used to recognize the gestures on the healthy side, and the corresponding gesture control instructions are sent to the exoskeleton to realize mirror movement. That's all the introduction to our work. Thanks a lot for your patience.